All right, today we are going to become software detectives. Our mission, if you choose to accept it, is to hunt down those little hidden culprits that make our digital lives, well, super frustrating. And it all starts with a question I think we've all asked ourselves at some point. I mean, we've all been there, haven't we? You're right in the middle of something important. Maybe you're checking out online, you're sending a critical message, you're about to beat your high score, and boom, everything just freezes up or crashes. It is so frustrating. But you know what? There's a reason it happens. And the answer? It comes down to these tiny, often invisible culprits we call bugs. They're basically just errors in the code that cause all this unexpected weird behavior. So for this explainer, our mission is to dive into the toolkit that the real software detectives, you might know them as QA engineers, use to find and squash these things. Okay, so our investigation starts with one of the most fundamental ideas in testing. I want you to imagine you're given a mysterious box. It's got some buttons, it's got a screen. You have absolutely no idea what's going on inside, but you can press the buttons and see what happens on the screen. That idea, right there, is our first method. This is what we call black box testing. The really crucial thing to get here is that the tester is acting exactly like you would, like an end user. They can't peek at the code, they're only focused on one question. Does this thing do what it's supposed to do from the outside? You give it an input and you check the output. Simple as that. It's a total outside-in investigation. But what if you could see inside that box? What if someone handed you the actual blueprints for how it was all wired together? Well, that leads us to a completely opposite approach, where our detectives get to see absolutely everything. And that, my friends, is white box testing. Here, the tester gets the keys to the kingdom. They have full access to all the source code. So they're not acting like a user anymore, they're more like an architect, checking the building's foundation and all the internal wiring. They design tests specifically to poke and prod the internal logic of the code. It's an inside-out perspective. So let's just nail this down. Black box testing is focused on the what. What does it do? This is the user's view. White box testing, on the other hand, is focused on the how. How does it work? That's the developer's view. And to build a really solid product, you absolutely need both. Okay, so let's jump back to our black box detective for a minute and open up their toolkit. What are some of the actual techniques they use when they're flying blind without the code? Let's talk about three really clever ones. First up is equivalence partitioning. The idea is, instead of testing every single age from 18 to 65, you just test one, like 25, and assume they'll all behave the same way. Smart, right? But then you have boundary value analysis, because bugs just love to hide at the edges, so you would test ages 17, 18, 65, and 66 specifically. And finally, you've got use case testing, which makes sure an entire journey, like going through the whole login process, works perfectly from start to finish. Another really important technique is called state transition testing. This is all about checking how the software moves from one state to another. Just think about an online shopping cart. It goes from a state of empty to items in cart to payment processing. This method just makes sure all those transitions are smooth and don't cause any weird glitches. All right, so we've seen what our outside-in detectives can pull off. Now it's time to see how the whole investigation changes when we hand over the blueprints, the source code, to our inside-out investigators. So with white box testing, the name of the game is coverage. How much of the code are your tests actually touching? The most basic level is statement coverage, which is like making sure you read every single line in a book at least once. A step up is branch coverage. This is like making sure for every if-then choice in the code, you test both the if and the then parts. And the most intense is path coverage, which tries to test every single possible journey a user could take through the code. That one is a real beast. Okay, so now we have all these amazing tools. Black box, white box, but there's a huge problem. You never have enough time or money to test everything. A good detective can't investigate every single blade of grass at a crime scene. You have to ask the critical question, where do I start? And the answer to that question is a strategy called risk-based testing. You can think of this as the detective's master plan. It's all about figuring out which parts of the software would be an absolute catastrophe if they failed, and then testing those parts first and testing them the hardest. Just think about it this way. It's pretty intuitive. A bug in the payment system, that's a 5-alarm fire, a total disaster, super high risk. A bug in the login page, still pretty bad, so we'll call that medium risk. A bug that makes a button the wrong shade of blue, yeah, that's low risk. A smart team pours all their energy into those high-risk areas first. It just makes sense. So as we start to bring our whole investigation to a close, what's the big picture here? How do you actually build an airtight case for a piece of quality software? Well, the secret is you don't just pick one tool. You use everything you've got. And here it is, the ultimate takeaway. The very best software detective teams, they combine everything we've talked about. They use black box testing to make sure the user's experience is great. They use white box testing to make sure the code itself is solid. And they wrap that whole effort in a risk-based strategy, so they're always focused on what matters most. You know, this quote here really says it all. There's no magic bullet. There's no single best way to do this. A truly great, reliable product is built by layering all these different investigative techniques on top of each other. Each one is designed to find a different kind of clue, a different type of bug. So I'll leave you with this thought. Now that you've had a peek inside the Software Detective's toolkit, if I handed you your favorite app, the one you use every day, and told you to find a weakness, where would you start looking? What's the first high-risk clue you'd go investigate? Thanks so much for joining us.